Ohm's law is one of the most popular laws of physics. But do you know why current flow through a conductor is directly proportional to the voltage across it? Let's see how George Ohm's brilliant mind worked while he derived this famous law. We need to approach things at the atomic level to understand Ohm's law. An atom always has a few electrons around the nucleus. In a conductor, some of these electrons will be loosely bound and free to roam around, as shown. This movement of electrons is completely random. If you calculate net electricity through an area, it will be zero. However, when you apply an electric field on the conductor, the electrons will start moving in a single direction with uniform speed. We call this speed drift speed. If you can figure out the magnitude of this drift speed, it is very easy to calculate the value of current. Here comes the brilliant way to find the drift speed. Let's follow an electron. The electron accelerates due to the effect of the electric field. However, very soon it will collide with the nucleus and its travel will come to a halt. Then it will accelerate and collide again. Let's assume the average length of this collision is L and the average time of the collision is T. The length of travel and time are connected through this equation, from which the average speed of the electron, the drift speed of the electron, can be easily derived as follows. So we have derived the drift speed of electrons. If we assume there are n free electrons per cubic volume of the conductor, current flow per area can be deduced as follows. Note that all the variables in this red circle are properties of a material which varies only with temperature. Let's group these properties together and form a new property. This property is known as electrical conductivity. This relationship says that the current density is proportional to the electric field value applied across the conductor, which is Ohm's law exactly. However, let's present Ohm's law in more user-friendly terms. Assume this electric field is generated by a battery. According to the definition of electric potential, we can deduce the electric field value as shown. If the conductor has a cross-sectional area of A, we can convert this to a relationship between voltage and current. This representation of Ohm's law is the most used one in physics and engineering. But remember, here we use the laws of classical physics to derive the drift velocity. Strictly speaking, the behavior of electrons in a metal is a quantum mechanics phenomenon. By using the classical physics method, we derived highly compromised results, yet it works well in most of the cases. Thank you for watching the video.